Today is the day for domain 3, and as we have already discussed about the domain 1 and domain 2, so understanding of this domain is pretty easy. The reason for the same is domain 1 covers about the management side, domain 2 covers about the again not the top management, about the middle management, like information security manager. And this particular domain, the domain 3, is about architects. So do you know why CISSP is so important and difficult to crack? Okay, I will tell you the reason for the same. The reason for the same is because CISSP covers the whole security from domain 1 till domain 8. So it covers every domain, covers some part of the security domains. So that's why CISSP covers the overall security domain. So if anyone want to go for this particular CISSP examination, he need to have either the implementation or practical knowledge, that is we call it as an experience, or the knowledge of the other domains or the work areas. Till now, we have already completed the two domains. Domain 1, that is security and risk management, and domain 2, asset management. In terms of work areas, you can say that domain 1 covers the work areas of CISO and ISO. And domain 2 mainly covers the work areas of security managers. And this domain 3 covers mainly the work area of security architects, because it is more about security architecture and engineering. But we need to understand what exactly security architectures mean, what exactly security engineering means. So if we are able to understand the same, it is very easy for us to understand the whole concept of this particular domain. And for this examination, for CISSP examination, it is very important. Okay, knowing the concept is very easy, but understanding the context of those concepts and where to implement those concepts is very important for this particular examination. And in CISSP examination, if you understand the context well, then you can answer the questions easily in the examination, right? So I'm starting this. So today, I'm assuming that you are a security architect, okay? And as a security architect, your role is to design and organize the component, processes, services, and controls which are appropriate to reduce the overall security risk associated to a system to a acceptable level. And this particular level of risk and the acceptable level is already we have discussed on the same in the our domain 1 and 2 both. In risk management, we have discussed how we can identify the risk associated to any particular system. And in the domain 1 itself, we discussed that once we present that particular risk to the top management and tell them that the overall costing to reduce that particular risk is more than the cost of the overall asset, then they can accept that particular risk. So all these acceptance is taken care as the top management level. And the very next team with which you will interact is the security engineering. So a security architect will interact with a security engineering team. And the purpose of a security engineering team is to implement the design which you will propose. It means whatever a security architect will propose, the security engineering team will implement those particular design. But the goal of both of you, a security architect and a security engineering team, is to protect the CIA, confidentiality, integrity, and availability of the data and of the information systems. And doing so, you need to follow a industry standard or government accepted enterprise or security architecture methodologies. Different methodologies are there, but in this particular domain, we are not going to discuss all those methodologies. It is out of the scope of this particular domain. So we can say that we will just see the principles. We will see what exactly principles are there, which are recommended by different standards, but we will not go into any particular architecture level document in this particular uh, class. But before designing any security architecture, you need a comprehensive risk assessment of the organization environment. Then only you can accurately have an idea of the risk which you need to address. Okay, and as a security architecture, you also need to understand that total 4 actions are possible on any risk, and these 4 options are risk avoidance, risk transfer, risk reduction, and risk acceptance. So when we are saying about a security architect, mainly he work on, out of these 4 he work on one, and that one is risk reduction. So whatever design he is going to make, he need to take care of this thing in his mind, that ultimately he need to reduce the overall risk. And the risk avoidance and risk acceptance are either at the business unit head or organization head. And the risk transfer is done using insurance, contract, or SLAs. As a security architect, you need to understand. Okay, so this is about the security architect. So as a, if you can map with whatever the ISC square CBK is saying, whatever the syllabus they have given for the CISSP domain 3, you can map all those with the functions of a security architect, right? So as a security architect, you need to understand the secure design principles, like uh, the option 1, which is given here, implement and manage engineering processes using secure design principles. So they are talking about the very first topic is discussing about the concept of security design principles. And then the second topic is to understand and the fundamental concept of security model. It means a security architect need to understand the fundamental concepts of security models also. Then only you can know how to select controls upon system security requirements, which is the topic number 3 here. And to do this, you need to understand the security capability of information systems. It means you need to understand the overall working of the whole systems, whether it is uh, I can say the RAM part, the CPU part, or the interaction in between those, whatever the TPMs are there, everything is covered in this particular topic. So it is, as a security architect, it is must for you to understand all this also. And also you need to understand the client based system architecture, server based system architecture, cloud architectures, then the ICS, then IoTs. So all these systems also you need to understand. Then only you can create a better architecture. Also, you should know how to assess and mitigate vulnerabilities in web-based, mobile, and embedded system. So you can say that when you are working as a system architect, system security architect, then you need to understand the overall concept of the IT system, right? And you need to understand the latest risk associated to those concepts. And also you need to understand about the latest technology which is available to mitigate those risks. And as you are going to use some crypto control, so you need to understand the basics and application of cryptography. That is what they have given in this particular topic 9, apply cryptography. And with all these, you need to understand the security principles of physical site and facility design. Ultimately, the security systems or the information system will be placed somewhere, and that particular part we will call as a physical site or the facility in which we are going to put those information systems. That's why it is important for you to understand the security principles of these physical sites also. And my friends, this is all about the domain 3 of CISSP. It means as a security architect, if you want to understand the whole concept of the overall CISSP, then domain 3 is the best place for you. You can, if you are a security architect, start CISSP from domain 3, right? And if you are, even if you are not a security architect, you need to understand how exactly a security architect works, what exactly his work role are, what are the parameters he need to keep in his mind, what are the principles he is working on. And this domain 3 will tell you all about this thing, right? So moving further, we will take the first topic, which is implement and manage engineering processes using secure design principles. So again, we are discussing here about engineering processes, but how? Using some secure design principle. So when we are saying that even when we are selecting any security control, or we are making an architect of any system, then we need to reduce the risk, and the best guide by of doing so is by using a defined set of security design principles. So we have to, as per CISSP, CBK, we can use two defined set of, like in the our last domain also, whenever we are going to use controls from somewhere, but how exactly we are going to use? We can use a predefined framework, and from that particular framework, we can start that these are the things which we require and these are the things which we don't require, right? So in this case also, you can use two frameworks, right? The first framework is S&S. I call it as S&S paper. It is about the protection of information in computer system. And the second is a ISO standard, which is 19 to 49 standard of ISO, which is about information technology, security techniques, catalog of architecture, and design principle for secure products, systems, and applications. So these are the two fundamental framework which you can take while you want to create an architecture of any particular organization, right? As a security architect, you need to understand that security must be part of a secure system design and not something which can be added later. Okay, so it means security start at the initiation step itself. It means the first step itself, we need to start the security. So we can say it should start from the inception stage. The reason for the same is if we start it from the inception stage itself, we will take care of everything, and it is very economical also for us. So fundamental to any security architecture is regardless of the design principles employed are the basic requirement in computer security, right? So let's discuss the S&S principles. So S&S paper has given total 10 principles. Initially they have given 8, then further they have added 2 more. These 10 principles are economy of mechanism, fail-safe default, complete mediation, open design, separation of privileges, least privilege, least common mechanism, psychological acceptability, work factor, and compromise recording. Work factor and compromise recording are added later on. But if you see the overall, all the security mechanism, all the security devices are using all these principles, right? And all the security architecture of any organization, they are using either one or two or multiple of these principles, architectural principles. So let's discuss, because it's very important for this particular domain and even for the whole CISSP. It is very important to know about all these principles. So let's discuss about these principles one by one. First one is economy of mechanism. The rule behind economy of mechanism principle is divide and rule. There is a universal rule that is divide and rule. Even in maths, whenever we face a tough problem, what exactly we will do? We will just break that particular problem into smaller chunks, and then we will work on each and every chunk, and then we will mix together those chunks so that we will reach the outcome of the problem. In real life also, whatever the bigger problems are, we can divide them into smaller, and then we can work on the same. So in security domain, same thing, same principle we can use, and here the name is economy of mechanism. So we can make things simpler and smaller, because as simpler and smaller the system is, it is easier to design, to assess, and to test those systems. So when the system as a whole cannot be simplified sufficiently, then we can consider about partitioning the problem so that the component with the most significant risk are separated and simplified to the extent possible, right? So even if you are not able to divide the whole system, we can just partition the problem which we are dealing with. So by separating security functionality into smaller isolated component, the task of carefully reviewing and testing the code for security vulnerabilities can be significantly reduced. And the best example of this particular principle, it means the best thing in our IT environment which is using this particular principle is the OS, operating system kernel, because it is completely separated, it is completely divided. It means it is separated from the OS itself, right? So the next principle is fail-safe default. The fail-safe default principle is okay. As per this principle, the control should be designed in such a way that in the absence of specific configuration settings or failure, the default is not to permit the action. It means whenever anything fails, then also everything remains safe, right? So it means the access should be based on permission. It means we should whitelist the access, not the blacklist. And the best example of this particular principle is the default firewall rule, deny all. And the third principle is complete mediation, which means that every access to every object is checked every time. And the zero trust model, which is the latest model in security, is based on this principle itself, the complete mediation principles. Okay, and the next principle is open design. So when we are saying open design, as per this, we should not use obscurity in security design. Means security should depend on keeping keys passwords secret, not the design of the whole system. Okay. And the next principle is separation of privileges. When we are talking about separation of privileges, it requires two actions, actors, or components to operate in a coordinated manner to perform a security sensitive operation. This control provides protection against fraud. And breaking a process into multiple steps performed by different individuals is called segregation of duty, which is also a separation of privilege only, or requiring two individuals to perform a single operation together. We call the same as dual control. That is also kind of a separation of privileges only. Forces the malicious insider to collude with others to compromise the system. So separation of privilege is more commonly called as separation or segregation of duties. The next principle is principle of least privilege. This principle is the implementation of the concept of needed to know, which says to restrict access and knowledge to only those items which are necessary for the authorized task or users. Okay, so if any particular user require access, require just access to read, then just give the permission of read only access. Do not give him the full permission of read, write, override, and delete. So next is the least common mechanism. It is about minimizing the sharing of component between users, especially when the component must be used by all the users. And this concept is used in transitive trust. And the next principle is psychological acceptability. As we are human and ultimately whatever security we are going to implement or any security professional is going to implement, we human need to face that particular security challenges. So this principle has also been called the principle of least astonishment. Means system ought to operate in a manner which user expect, because best security control is of little value or no value if the users are able to bypass it, work around it, or ignore it. And the ninth principle is about the work factor, which refers to the degree of effort required to compromise the security control. And the last principle by S&S paper is the compromise recording. And our SIM or logs we are keeping in our servers and devices is the best example of the same. Okay, moving further, the next is ISO 19249 standard. This standard describes the architectural and design principle to be used in the secure development of systems and applications. ISO 19249 specifies 5 architectural principles and 5 design principles. So let discuss about the architectural principle first. The 5 architectural principles for ISO 19249 are domain separation, layering, encapsulation, redundancy, virtualization. Okay, let's have an overview of all these 5 principles. First one, the domain separation. It describes enclosing a group of components together as a common entity. As we use VLAN, VLAN is a perfect example of domain separation. We create different VLANs for different kind of security servers. We are having security categorization. We are having, so we can create different VLAN for the same. So whatever VLAN configuration at one for one server in that particular VLAN, because it is and other server, whenever we are putting another we are adding one more server in that particular category or in that particular VLAN, that is sharing the same type of security categorization as the first one. So domain separation, this is the very perfect example. VLAN is a very perfect example of the same. The next one is layering. Layering is the hierarchical structuring of a system into different levels of abstraction, with higher levels relying upon services and functions provided by the lower levels, and lower levels hide or abstract details of underlying implementation from the higher levels. And OSI, Open System Interconnection, is a best example of this. In OSI, we have different layers, and every higher layers just abstract or hide the functionality of the lower layers and provide services to the higher layers. So that's how the layering principle works. Next principle is encapsulation. As per this, objects are accessed only through functions which logically separate functions that are abstracted from their underlying object by inclusion of information hiding within those higher level objects. And the best example of the same is device driver. So device driver, they will just interact with the OS, and with the OS, the user will interact. So user will pass on the command to the this operating system, and then operating system further encapsulate the command and then give it to the device driver, and device driver further encapsulate it and then give it to the particular device from where exactly the device will operate or do the function. The next principle is redundancy, which is designing a system with replicated component so that the system can continue to operate in spite of errors or excessive load. And BCP or DRP, which we have discussed in the domain 1, are the perfect perfect document which are using the principle of redundancy. And to implement this redundancy, we use techniques like RAID and control and cloud. Next principle is virtualization. So virtualization is a form of emulation in which the functionality of one real or simulated device is emulated on a different one. Okay, and virtual machines and containers are the perfect example of this particular principle. Next is the 5 design principles given by the ISO standard 19 to 49. So the 5 design principles are least privilege, attack surface minimization, centralized parameter validation, centralized journal security services, preparing for an exception handling, right? So let's have an overview of these 5 principles also. Okay, in as per exam point of view, you need to understand these principles. Do not go in detail of these standards. That's why I'm giving a complete overview, which is required, which is the only requirement for this particular examination. Nothing more for these standards or for this document is required as per the exam point of view. So list privilege. As per this, keep the privileges of an application, user, or process. It means either the privilege of an application, user, or process to the minimum level that is necessary to perform the task. So you can map this particular to the principles of the S&S paper also. So there also same principles are using, just the name are different and the categorization of those functions of security are different, right? So the purpose of this principle is to minimize damage. Okay, if any particular user, application, or process is compromised, and if it is having the least privilege, then there will be minimum damage to it. Okay, the next principle is attack surface minimization. It is about reducing the number of ways the system can be accessed. It can be done by disabling or blocking unneeded services, ports, using IP whitelisting to limit access to internal API codes that need to be publicly accessible. And system hardening is a perfect example of the same. So whenever we are hosting any particular web server, a web server do not require a FTP server. So will disable those extra services which is not required on that particular web server. And by doing the same, what exactly we are doing? We are minimizing the attack surface on the server. And this is a this is a design principle given by the ISO standard 19 to 49. Next is centralized parameter validation. So this is all about centralization. This particular principle is all about centralization. It says whatever you can do, whatever you can do, try to make it as centralized as possible. So if you want to do it, do authentication in your environment, try to make it centralized. If you want to do any privilege management in your environment, try to do it centralized. If you want to keep logs in your environment, try to make it centralized. So using a single library to validate those parameters enables the necessary capability to properly review and test the library. The reason for the same is you can properly manage the whole thing and you can properly test your environment. Okay. The next principle is centralized journal security services. It means, as the name suggests, it is about the journal security services. Okay, like logging, key management, authorization, all these are the journal security service which we need to centralize. Then the fourth one is preparing for error and exception handling. So system must ensure that errors are detected and appropriate action taken, whether that is just to log the error or to take some action to mitigate the impact of the issue. And the perfect example of the same is IPS, intrusion prevention system. So IPS, what exactly it will do? It will just uh, analyze the traffic. If it found that particular traffic is malicious, then it will check what exactly the condition of the manager is given to perform. Like whether it will just log that particular attack or whether it will just create a alert for that particular attack. So either it is prepared, the IPS is prepared to accept any particular malicious packet or and do a particular operation for the same. Similarly, whatever application we need to develop, web application or other application, mobile application also, they should be prepared for error and exception handling, right? Okay. So moving further is defense in depth. So over these principles, whatever principles we have discussed and design principles and other principles we have discussed just now in S&S paper and this ISO 19249 model. So both of these principles, the principles from both these documents, we can implement somewhere. And once we implement them, and one we will get a model. And this particular, there's a very good model of the same, that is defense in depth model. So in this security model, a combination of security controls are used, and the impact from the failure of any single control can be reduced, if not eliminated. Means using multiple security control at different layers. Like in this particular example, in this particular figure, you can see we have implemented layers, different layers, like the application and data security layer, the host security layer, then the network security layer, then the physical layer, and ultimately the documentation layer. So ultimately they are different layers. Even if one particular layer control fails, then the attack can be blocked at the next layer. This is what about defense in depth. And in practical, we are using defense in depth model only. We use combination of multiple model, but defense in depth is a example of the same. Like whenever the traffic is coming in our network, so at the first level, it will enter into the router. Once it will enter into the router, maybe in the router, we will use some IP whitelisting or blacklisting policies. So as per that particular policy, it will allow or disallow that particular traffic. Next, if the traffic is allowed from that particular location, it will reach the firewall. The firewall will decide at what particular port the traffic will be accepted or blocked. And finally, it will reach the IPS. So once, even if it is allowed, the traffic on port number 80 is allowed by the firewall, then the IPS will check what exactly the content of that particular packet is. If there is any malicious content, it will match it with the particular signature and block it. And even if it will allow it and it will reach that particular server, then we can use a application level firewall, which will block that particular packet if it is malicious at the application layer, right? And if any particular system is compromised locally, it means we insert a pen drive into that particular system, then the endpoint security will come in picture. Okay. And to implement all these all together, we use some policy and procedure document. And this is what defense in depth model is all about. So finally, as a security architect, you need to know how and where to use all these security principles. So when considering the applicability of security control, realize not every control is appropriate for every situation. You must also consider that some security principles directly conflict with others. So you need to make a careful consideration and judgment before making the appropriate choice of the principles to follow. Okay. So in the next slide, you can see we are discussing the very first topic, implement and manage engineering process using secure design principles. And whatever we have discussed today is covered in this particular topic. So information system architecture must meet the business and security requirement. That's what our role of a security architect is. He need to take care of this thing. Also, security should be built into the information system by design itself. Okay, so from the very initial state itself, it should be incorporated into the system. Security must be balanced with business requirement. So the security should not hamper the work of the, it should not hamper the business requirement. It should not hamper the business, running business. And the trade-offs will be needed between security and business to achieve balance. So there is, it is the work of the security architect to make a particular balance between the security requirements and the business requirements, right? Okay, so with this friend, I want to say that because today is the basic understanding of the security architecture, design and principles, that's why it's very important for you to understand all these security designs and principles. Once you are able to understand these security designs and principles, 50% of the topic is already covered. In the rest of the topic, like you can say these particular topics, like understand the fundamental concept of security models. So if you know the security principles, then only you can understand about the security models and what exactly security principles are used in different models. So my suggestion to you is just to go through these slides once more and just it means understand, try to understand these security principles a lot. Okay, that's a suggestion from my side, because in the examination also 5 to 6 questions you will get depending on these security principles, because these security principles are not used in this particular domain only, it is used across 5 to 6 domains, right? So you can say 5 to 6 questions are going to come on these particular security principles only. So my suggestion to you all is just go through these particular security principles. I have already added on Quizlet, I have already added the content to revise for this particular security architecture and engineering principles. And then it is very, once you understand these principles, then easily you can understand the models, the system security requirements, it means the control requirements, the security capabilities, that is technical, but technical in the sense it means we need to discuss about the system architecture. Okay, but if you know the security principles, then and you know the security architecture, then it is very easy for you to work on this also, right? So today I'm ending my session here itself, and I'm sharing the link. I'm sharing the link of this PPT, so it will be easier for you. Just revise, revise well this thing, and try to understand the security principles well. Okay, whatever security principles we have discussed, try to understand them well, and you can practice the same using the Quizlet, right? Okay, thank you, thank you very much.